I would like to thank the South African Archaeological Society for inviting me to give this talk today. I've presented and published on enslavement and slavery in Cape Town as a node in the Dutch East India Company's seaborne empire. Is it possible to read the body and written archives of another group of marginalized people who lived and died in another place, decades after the emancipation of enslaved persons at the Cape, and find similarities in certain aspects of their lived experience? The first part of the talk will provide one of the definitions of bioarchaeology. Secondly, we will explore what we can and cannot ask of human remains. This will be followed by two examples of how different isotope systems can elucidate aspects of migration and diet. We will also give the most probable interpretation of our findings. Ultimately, we'll discuss the possibility that the recruitment of labor in society followed a similar pattern over the course of more than a century. One definition of archaeology states that it is the study of human remains from archaeological contexts. The field emphasizes integrative, interdisciplinary analysis of the links between biology and culture in past societies. This approach has contributed to an informed understanding of the range of social, behavioral, and economic conditions and circumstances that have shaped the human experience. The approach, in effect, is a telling of stories about aspects of human life in the past by treating the body as an archive. What kinds of questions can we ask of the body archive? What aspects of the lived experience of enslaved persons can we elucidate by studying the body archive? And what limitations are associated with this approach? Migration is one aspect of early life that we can explore using strontium isotope ratios. We can determine whether individuals migrated and the extent of migration within and between populations. It is possible to make a crude timeline of an individual's movements. The information is captured by the enamel of teeth that develop at different periods in early life. It's necessary to determine the range of strontium isotope values of the underlying geology where burials are found. This allows us to identify migrants. We can determine differences in diet in youth and in later life by using the carbon and nitrogen isotope systems, which give us an indication of what types of grains and proteins were consumed by individuals and groups. By measuring carbon and nitrogen isotope values of dentine and rib collagen, we can gain an understanding of diet in early and later life. Reference data from the faunal remains associated with burials is required for comparison. Some pathologies can also be detected isotopically. Single amino acid analysis, for instance, shows promise in detecting tuberculosis. What we cannot ask of the body archive is exactly where migrants hailed. This is due to the fact that strontium isotope values are not unique to one place. However, with the use of other lines of evidence, it is possible to narrow down probable origins. For instance, we know that enslaved persons at the Cape came from the Indian Ocean basin, particularly Mozambique and Madagascar, India and Sri Lanka, and the Indonesian archipelago. Knowing the crude geology of these regions may give us an inkling of where individuals may have come from. However, in the Indian Ocean world, enslaved persons could possibly have been captured or brought inland before coming into contact with the Dutch, which complicates tracing origins even further. Moreover, the resolution provided by a sampling method may not fully reflect individual migration histories. It is, however, possible to generate maps known as isoscapes that reflect isotope ratios of different areas as a reference tool. This is not feasible on the scale of the regions enslaved people originated from. Carbon and nitrogen isotope values of faunal remains are often used to determine different aspects of diet and to understand resource exploitation. Modeling has also become common to improve dietary assessment. Studying the dead, introduces bias to bioarchaeological studies, as these individuals may not be representative of the population at large. Small sample populations also beg the question whether they are representative of the larger group. Finally, the lack of ego documents from this period makes it difficult to understand the horrors associated with enslavement, not least of all having one's personhood disregarded. I will give examples of the use of strontium isotope ratios to determine migration patterns of enslaved individuals. The graph that you see here is a plot of the first molars of enslaved persons' strontium isotope values. The first molar develops until approximately 3 years of age and thus captures geological information from that period and place of residence. The band that you see is a crude strontium isotope range for the Cape. As we can see on the far left, there are individuals born in younger geologies than the Capes, and to the far right, individuals born in older geologies that are associated with higher isotope ratios. It appears from statistical analysis that enslaved women came from a smaller geographic area than men. We cannot state this with certainty, but this may have occurred due to the preference for enslaved people with certain skills. The strontium analysis of first, second, and third molars demonstrates that some individuals moved between different geologies in early life. The extent of this is not obvious from the written record. Most individuals' strontium isotope ratios, however, are consistent with local origins. We've highlighted the strontium isotope ratios of individuals who appear to have experienced residential stability in early life. The one individual lived in a region whose underlying geology was younger than that of the Cape, perhaps the islands of Far East Asia. The other individual, on the far right, originated from a particularly radiogenic and therefore old region, perhaps Mozambique. The next example will demonstrate how the carbon and nitrogen isotope systems can be used to compare two populations, and in this case lead to complicated results, reminding us that the more lines of evidence considered to answer historical questions, the better our understanding of the past. The first two plots of carbon isotope values show a significant difference between populations. This is more pronounced in the population's nitrogen isotope values on the right. Both differences are statistically significant. As we shall see later, it is also significant that the use of the burial ground where the first population was found was in use before and after the emancipation of enslaved people at the Cape. There are a variety of reasons that can explain the significant difference in both carbon and nitrogen isotope values between the two populations. It could be that after emancipation there was a change in diet, leading us to wonder whether isotopic analysis may reflect individuals' newly acquired freedom. Many factors can cause increases in nitrogen isotope values, one of which is consumption of salt. We know that salt was often used to preserve meat at the Cape. This could explain the change if we assume that the carbon and nitrogen isotope values are not correlated. Another factor that could explain the higher nitrogen isotope values is stress, such as illness and malnourishment. Could the one population include those sick from seafaring and poor diet? Perhaps. Perhaps the answer lies, as mentioned earlier, in isotopic analysis of not only bulk collagen, but single amino acid analysis. Based on modeling that considers the most probable dietary inputs accessible to enslaved persons, including marine resources and grains such as wheat, which was grown at the Cape, we can tentatively conclude that the population that died before emancipation relied mainly on plant protein. This was the case despite the availability of fish as a cheap source of protein. Perhaps after emancipation, formerly enslaved individuals could access more marine and terrestrial protein. If indeed this was the case, the finding is very significant. Emancipation seems to have resulted in access to foods that enslaved people did not have. Isotopes reflect life before and after emancipation. We have to be careful, however, to keep in mind that the number of individuals studied is small. Perhaps the results are not representative of all enslaved and formerly enslaved persons. Studying other populations is thus necessary. From these data, we have demonstrated that some individuals experienced migration before arriving at the Cape. Perhaps they were traded and transported in indigenous networks. A crude understanding of the geologies of the Indian Ocean basin could tentatively assign origins to a few individuals. As stated before, the horrors, dehumanization, and uncertainty experienced by enslaved persons cannot be quantified by isotope analysis. Based on these findings, it seemed obvious to us that we should explore another form of labor exploitation. Upon reading further, striking similarities became obvious to us. In particular, the pattern of dispossession and ultimate labor exploitation evident at the Cape and the Rand, where deep-level gold mining required cheap and abundant labor. The relationship between settlers and indigenous groups inevitably soured, partly because of the tussle for resources. Then came wars, which guns and horses would eventually win. Once defeated and dispossessed, African societies had no option but to provide their labor cheaply. This is not to say that different kingdoms and groups lived in peace and shared resources equally. African societies also practiced diplomacy and aggression to their advantage. Once again, we relied on the strontium isotope system and written records to attempt to understand what life was like for the workers recruited for the mines. It is well known that the South African migrant labor system sourced workers as far north as Malawi. What may not be clear is whether migration was common before the discovery of gold. Two populations were subjected to strontium isotope analysis, one from the Rand and the other from the Free State. The individuals from the diamond mine in the Free State seem to have been from the area around the mine, which is not particularly radiogenic. On the other hand, the few individuals from the Rand displayed a wider range of strontium values, some of which were from particularly radiogenic regions. As can be seen, the northeastern part of the country has a complex geology, which will make it difficult to even begin to deduce where miners originated. The archival material shows some worrying trends which have been observed and published. The bar chart represents the mortality of workers who originated from regions north of the Tropic of Capricorn. Their death rate was multiple times greater than that of the rest of the population. We know that workers were quarantined and inoculated before being released into the general population. However, they often suffered from tuberculosis, pneumonia, hookworm, dysentery, and other diseases due to their poor living conditions and working conditions. In 1903, there was an epidemic which resulted in a death rate of 71.7 deaths per 1,000 per annum. The life expectancy of a worker in that year was 13 years after the commencement of work in the RAND. The time when a worker's chances of survival were 50%. The time when a worker's chances of survival were 50% was 9 to 10 years. I'm sure you're taken aback by these numbers, but considering the congested and unsanitary conditions workers endured, this type of calamity was inevitable. There is still a great deal of work that needs to be done. We need more morbidity and mortality data from the archives. Comparisons between health status and death rate of Africans and published data on European workers should be explored. Despite the time period covered by the study, it would be instructive to measure trends over a longer period to determine whether the lives of the workers improved with time. It is also necessary to generate more isotopic data and perhaps turn to modeling to estimate the strontium isotope values of the underlying geology of possible regions of origin. This crude method is the only feasible way to determine the local signal of all the regions that workers came from. Tuberculosis, which resulted in many deaths, can be detected from serine carbon isotope analysis of bone collagen. With more data, we'll be able to weave a textured history and hopefully answer the question whether time, place, and context made a significant difference to the body archives of the marginalized.